Hello, my name is Değer. My number is 2204030442. The scenario I've chosen is F, scenario F. The real world motivation behind this scenario is to, in an industrial areas, water, spilled out water can be so little, it can damage circuits or electronic things, or even make the environment slippery and makes the workers slip and hurt themselves. So a critical leveled water is something to deal with immediately. In industrial scenarios, almost all scenarios, some scenarios, you should drop everything and deal with the water itself. Hardware register. Walk through hardware setup, and I used first of all a switch, if I can show you. A water level switch, and if the level increases, this silicon cylindrical shape increases to and turns the switch on. It's closed circuit. It becomes a slow closed circuit, and it makes the output of this op-amp high, and the output goes to STM32, just not 32, and makes the LED pin on in my code with interrupt. And when I push the button here, this button, it resets turns off the LED, but not while the level is increased. Water level is still increased in critical levels. So each register configured. I first of all used EEE316 ENR register to enable the GPIO clock with this in CMSIS bit. I used the mother as to make PA1 as act as output with these values also. O-typer, and with this register make the PA1 as push-pull, and with this BSRR register here with this byte, I'm resetting the PA1, so the system, when the system starts, it doesn't turn on, the LED doesn't turn on. Otherwise, if I skip this part, this register here, the LED could turn as on if it was the state when the system closed earlier. So I would have to push the button at least once, while not water level is not in critical levels. So it would be unnecessary thing to do. So live code demonstration. Go through main.c. In here I including the important necessary header files. In here I am defining which pins I'm using as what, as set pin. I'm using PA1, PA0, as reset PA14, as output PA1. With this configuration I can set whatever pin I want as writing like this or that. So here I define the event flags, my set flag and reset flag here, and I'm with volatile keyword, and using them here in callback functions. Yes, you wanted me to show the callback functions too. Yes, callback functions, and setting the flag according to the callback function. In set, event flag set is set, reset. And here in process event, whenever something happens, in an interrupt comes, whatever it is called callback, flag sets their flag, and here we compare if the flag is turned on or set high or low. How? Low. If set flag is turned on, high setted, then first of all we would reset the flag here, so it doesn't becomes a loop in this function, and output on. As this flag is set, output turns on. As the reset flag is set, the output turns off. This should be PA14, of course. It was one of my earlier tries. And in here I'm configuring the structure, exti set structure and reset structure, and initialize them. In the while, I'm using VFI and doing the, if the interrupt comes, process event is happening here. It is everything we do is waiting here and not callbacks, because callbacks should be fast. They are part of interrupt, and while they are they been do it, my system can not do anything else. So live result and analysis demonstrate the working system. Discuss does the interrupt during the main loop. Yes, let's show my demonstration of the system like this. Yes, as you can see, this water level is not in critical level, and I'm turning my STM32 on, so turned on. I'm pouring the water, I'm pouring it fast. As we can see, the LED turned on, and I can't set it off as the water level is in critical levels. And when I pour some water and decrease the water level, I can turn it off, turn the LED off by pushing the button. It responds immediately because I used the interrupt system here. Yes, in the water, as the water level increases, it turns on. And if I push the button in critical levels, it doesn't turn off anyway. With this, and turn it off like this. Does the interrupt respond immediately during a long main loop task? Yes, interrupt respond immediately. What's your event counter showing some yellow LED turning on? Conclusion: summarize the engineering lessons. When should I practicing versus polling? Yes. The engineering lessons I learned was how to use interrupts in STM32, and how to use interrupts with hardware, real life hardware systems, and the importance of fast response in industrial areas, and how to use water level sensor. An engineer should choose interrupts if something should have happen immediately, when you have to drop everything off and deal with whatever is happening for the interrupt to happen. But polling is easier way. So if it is unnecessary to do something fast and immediately, an engineer can choose polling too, of course. Mention challenges you encountered and how you solved them. The challenge I encountered was button shouldn't turn off the LED when the water level is still critically increased. So in critical levels, whenever I push the button, it shouldn't turn off the LED. It was the challenge I encountered, and I solved it with NOT gate. So whenever water level is increased, output of, as I can see, show. When output is water level is increased too much, the output of this op amp is turned 1, and it goes a pin and a NOT gate, and the output of NOT gate goes to this part, this button's energizer as energy, positive voltage source, and when the output is 1 from op amp, the output of NOT gate is 0. So even if I push the button, the positive voltage of this button is 0. So the LED doesn't turn off, because PA14, as I used as a reset button, doesn't get the high voltage. That was all. Thank you for watching.